Hey guys, welcome to the next lesson. This is the last lesson in this unit. We're going to solve some problems with vectors. So just quickly, like when two or more forces act on an object, we can use vector addition or vector subtraction to find the magnitude of the resultant vector. Happens a lot in physics, so vectors are very real life application of problems you might find in physics. The direction of a resultant can be found using trigonometry, and the direction may be expressed as an angle relative to one of the given vectors, or as a quadrant bearing or true bearing, like we saw in the earlier lessons. Let's go through an example, and I'll show you kind of how I would set these up, and we'll look at how do we actually do the steps of it. So, for example, Mary is walking to the library. It is 3 kilometers east and 2 kilometers north of her current position. Determine the magnitude of the resultant displacement to the nearest kilometer, and we're going to determine the quadrant bearing of the resultant displacement to the nearest degree. So we're going to figure out like what direction she actually has to go in to get to the library. So the first thing I'm going to do, some of the questions will ask you to do this, some won't, but we're going to draw a diagram. Now, when we're working with vectors, what I usually do is I will draw a north. I'll draw a compass. East, west, because it will be nice and easy to put the vectors on the compass and then find out the direction and whatnot. So let's do our vectors. Mary's walking to the library. It's 3 kilometers east, 2 kilometers north from her current position. So I'm going to have her current position be right in the middle because that's where she's starting. She's going to walk 3 kilometers east, and then she goes 2 kilometers north. Determine the magnitude of the resultant vector. So the resultant vector is from her, we're just adding. So we're starting at her current one and going to the finish. So that's her resultant vector. So I have a nice little diagram where I can actually see the vectors. I can see my resultant vector. I can use this to find out what is my magnitude going to be and what is my bearing going to be. Now the nice thing with east and north is we have a nice little 90-degree here just because of the directions. So for A, we're going to determine the magnitude of the resultant displacement. What's nice about this one is because we have a 90-degree, we can use a Pythagorean. If you don't have a 90, you're going to have to use your cosine law or sine law to be able to find out that third side. But in this case, we know that that is 90 in between, so we're going to use Pythagorean. So r squared is going to be 3 squared plus 2 squared. So 9 plus 4, 13. So r is root 13. So we know the magnitude of that. If you want, I mean, in this case, I'll let you guys, that's root 13 is the exact value, but if you want, let's figure out what it is. And it is approximately 3.6 kilometers. Okay, so we have the magnitude, to the nearest kilometer. So it's between 3 and 4 kilometers, but I'm going to round it up to 4 kilometers. Part B says, what's the quadrant bearing of the resultant displacement to the nearest degree? So we have to find out what is this angle. And then we'll find out what is our actual bearing, because remember that the bearing goes from here to here. So this is our bearing. So let's find the angle, and we're going to do that using trigonometry. I know these two sides, which if we go back to trig, this was the opposite and this was the adjacent. So I can use tan of the angle is equal to the opposite over the adjacent. No, I wrote that. And I'm going to calculate that. This is 0.666. Repeating, and I'll calculate theta with our inverse. 0.66666. 33.7 degrees for that angle. And if I wanted to do, so I have to change it a little bit to get that bearing. So I'm going to do 90 degrees minus 33.7. So I get that that bearing is 56.3 degrees. So remember, you want to write it, it's north 56. Let's make it nicer, guys, sorry. North 56.3 degrees to the east. So there we figured out the magnitude. The magnitude and the direction. Using stuff we've already learned in previous lessons, like the Pythagorean theorem and our primary trig ratios. Don't forget that there is also the sine law and the cosine law that you could use to do this, but ideally, like, set it up with a diagram so you can see exactly where the vectors are and what direction they're going, and then solve it accordingly by making it into a triangle. Good luck with the practice stuff, and I'll see you guys later.